Unit 4, Lesson 3, Example 3, two-column proof. So annotate your diagram with the given information, so we'll start with that. AB is congruent to AC. XB is congruent to XC. And let's write our methods down. We have side, 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 and angle, side, angle. They gave us two sides, so that means that angle, side, angle is going to be out. And they didn't tell me any information about the other angles. I could do some angle stuff, but your proof is going to be really long, and I don't think many of us would go to this method right away. So I'm going to say that side, angle, side is out for right now. So I'm looking for another side between these two triangles. And again, we're looking at triangle AXB to be congruent to triangle AXC. And so if you notice when I highlighted those, there's a portion of that highlight that turned green. Well, that's a common or shared side. So we're going to be able to use that AX is congruent to itself in our proof. So let's set up our columns. Right, and we know that our starting point is always the given. And I know that I'm going to end this proof with triangle AXB congruent to triangle AXC. And right now I know that my method is going to be side, side, side. Okay, I don't know how many steps I'm going to have before, but again, I can always start with what I know at the beginning and where I'm going to end at the end. And I already know what method I'm going to be using here, so I can fill that in without actually numbering it. So they gave me two sides. I need the third side. And we said that AX is congruent to itself and part of both triangles. So that is reflexive property. And so my final statement, now that I have all three sides, is that the two triangles are congruent. So identify the ridge of motion that would map one triangle onto the other. So that would be a reflection over AX would map one triangle onto the other. And that's it.